Hello class, today we're looking at Chapter 5, Lesson 2, Solving Systems by Substitution. You can use systems of equations to compare the cost of two phone plans, say, as an example. To solve a system, you can solve one of the equations for one of the variables. This is called the substitution method. So we are going to look at substituting using these two equations. So the first equation we have is y equals 4x minus 1. So how this is y equals, we can then go ahead and substitute this in for y. So our equation will now be 2x plus 2 times 4x minus 1 equals 3. Let's go ahead and use the distributive property. Get this distributed into both of these. So 2x plus 8x minus 2 equals 3. Combine like terms. 10x minus 2 equals 3. Let's isolate the x. Add 2 to both sides. 10x equals 5. Right now it's being multiplied. The opposite of multiplying is divide. Divide by both sides. This can be divided by 5. And that's going to equal 1/2. Therefore, x equals 1/2. So then we need to take 1/2 and plug it into one of these equations. So if we then go 2 times 1/2 plus 2y equals 3, we can solve for y. 2 times 1/2, that crosses out and that's just 1. So then we have 1 plus 2y equals 3. Subtract 1 from both sides. 2y equals 2. Divide 2 from both sides. Y equals 1. So our answer should be x equals 1/2. Y equals 1. We then can take those numbers and substitute it in to just verify that that's correct. So let's take them to this first one. Y equals 1. Equals 4 times 1/2 minus 1. 4 times 1/2 is 2. 2 minus 1 is 1. 1 equals 1. Yes, that is correct. So you go ahead and try this next one. Come back to me when you're done. Okay, so I went ahead and substituted this equation in for the y, and that's how I got this. Did like terms, got rid of the 1, got 3x equals -3, got rid of the 3 on both sides, x equals -1. I plugged that into that first equation, -1 plus 1, therefore y equals 0. Just to be sure that that was correct, I plugged both the x and the y into this equation and verified -2 equals -2, so therefore that is correct. So, solving a variable using substitution. So you might get thrown at you two equations and one of them is not solved for one variable. So you have to first solve for a variable. So this second one has a y that's by itself. So let's keep that y on that side and get rid of this 3x. So we're going to add 3x to both sides. So now we have y equals 4 plus 3x. So now that we have a variable where y equals, we can then plug it into this equation. So then we have negative 9x plus 5, plug this in, times 4 plus 3x equals negative 1. Go ahead and distribute the 5. So we now have negative 9x plus 20 plus 15x equals negative 1. Combine like terms. That's going to equal 6x plus 20 equals negative 1. Let's go ahead and get rid of the 20. Oops, not add, we're going to subtract 20 from both sides. So then we have 6x equals negative 21. And when we solve that, we're going to divide by 6. X equals, let's go ahead and divide that in there. 6 into 21. 6 times 3 is 18. 19, 20, 21, 3. So that's going to be 3 1/2. So you could write it as 3.5. So x equals 3.5. So now we want to plug that into the original equation. So we have negative 3 times 3.5 plus y equals 4. This is going to equal negative 10.5 when you distribute it in, plus y equals 4. So we're going to add 10.5 to both sides, and I get y equals 14.5. Oh, I just see what I did wrong. Whoofy. Okay, so this should have been a negative 3.5. So then this is a negative, so then this turns this into a positive. So then I'm actually subtracting here. So then this equals 4. Minus 10.5 is going to equal negative 6.5. So x is negative 3.5, y is negative 6.5. And that is your answer. Okay, you try this next one. Come back to me when you're done. Okay, so after solving, so I solved for this one for y, and then I plugged that number into this y and got this equation. When I solved, x equaled negative 6, and then I took negative 6 and I plugged it into this equation over here. So when I solved that one, I got y equals negative 9. And just to verify, I took these numbers and I plugged it into this equation. And yes, negative 18 plus 18 equals 0, so those are correct. Okay, so now we had talked about a phone plan. So let's look here. Nina's phone plan costs $42 per month plus 20 cents per text. Rick's phone plan cost $45 per month plus 10 cents per text. For what number of text will their plan cost be the same per month? What will the monthly cost be? So first thing we need to do is write a system of equations. So here is Nina's phone plan in equation form, and here is Rick's phone plan in equation form. And then we can substitute. So this particular one here, they just put y equals, so they substituted for y, so then we got this equation. When we solve for x equals 30, we're going to plug that into one of the first equations, or the first equation, and we get that y equals 48. So for 30 texts per month, both plans will cost $48. That's the break even where the lines, the graphs cross. Okay, so now you tried this one. Here you need to see Nina's also. Okay, so Juan's phone plan costs $40 per month plus 40 cents per text. For what number of texts will Juan and Nina's plans cost the same per month? What will be the monthly cost? See if you can figure that on your own. Press pause, come back to me when you're done. Okay, so I got that at 10, for 10 texts per month, both plans cost $44. So I first made each of these equal to each other, solved for x, got x equals 10, and then I verified by plugging x into both equations and got that they both equaled 44. So therefore 10 texts were the breaking point. And that is how many both plans cost 44. That'll be when they cost the same per month. Okay, so now let's take a look. There are definitely more than one way to solve things. So solve the linear system. So here's our system. Negative x plus y equals 5, 1/2 x plus y equals 8. Jasmine says she can solve the system by substitution. First I solve the equation negative x plus y equals 5 for y to get y equals x plus 5. So then she writes the second equation, she substitutes that in, simplifies, divides each side, gets that x equals 2, and so then she can substitute 2 in for the equation to solve and get y equals 7. The solution is 2, 7. One way to do it. Kevin says, well, I can solve the system by graphing. I can make a table for each equation in the system. Then I can graph the lines. So he makes two equation tables and then graphs and sees where the two lines meet, and he gets the solution to the system is 2, 7. They are the same. There are more than one way to solve these equations. Please do what feels comfortable to you. So go ahead and solve this one on your own. Any way is correct. I want you to be able to decide which way you prefer. Come back to me when you're done. Okay, so I went ahead and solved it both ways. The first way I did was using the substitution method. So I solved for y, plugged it into the other equation, solved, got x equals 3, plugged 3 in, and got y equals 1. So that's how I came up with this. And then I decided that I would try the other just because you may choose to do that. Plugged in these random numbers here, 0, 1, 2, 3. Same for this one because this one is a fraction. Anything that's divisible by 3 makes it so that it is no longer a fraction, which is helpful is why I jumped to 3. But then I did notice that they both had this same one in it. I did graph them, and sure enough, they cross at 3, 1. So both of them, I got the same exact answer, 2 different ways to solve it. I personally prefer the substitution method, but you do whatever works for you. Your homework tonight is page 156 and 157, number 1 through 17 odd. Happy homeworking!